Kevin?
Yeah, happy. Yeah, finding a time. I kept having conflicts, so
No worries.
let's see. You see that? There we are.
Yep.
Looks good.
So yes, this is a project that was funded in the last HDEE call, and it's just gotten through all the administrative hoops actually, and can get access to the funds now. So yeah, I'm the PI of the proposal, but there's a lot of other people I'm working with. We have Benoit Tremblay here at NSO, who has a lot of experience in machine learning and Python development and some of these techniques. Parker Lamb, who has started working with us. He's a undergraduate doing some development. And then several researchers, Ivan Milic, Mihalis Matidakis, and Jana Kautsi, all lending some domain and Python knowledge to the project. So what is the focus here of the project? It's dealing with all these images we have of the sun. So I'm going to talk about feature extraction. We think about that sometimes in terms of full disk images and identifying sunspots and filaments and things on full disk images. But the goal of this effort is more looking at the feature extraction of sort of small scale structures, high resolution images from the ground, from space, whether that's, the IRIS or other space NASA missions as well. Solar Orbiter will have a lot of high resolution imaging as well. And we take a lot of different images at a lot of different wavelengths because they tell us about different parts of the solar atmosphere. And so we try to build up this sort of 3D view of the sun, going from the photosphere here on the left and up into the chromosphere and the corona. And so, these are sort of large scale images, and then you see these sort of zoomed in versions where you can see some of the structures, all the different structuring, and we'd like to be able to identify and track these features. So on the left, you see the granulation, and then you see all these little bright points embedded in what we call the lanes, these dark regions between them. Those are parts of the magnetic field as they appear in the photosphere. And when we go up into the chromosphere, we see these get extended out into these sort of what we call fibrils, these sort of long, darkish or light and dark structures. And these are all tracers of magnetic field. And the magnetic field is what we are trying to understand in the sun. And so these are single time snaps at single wavelengths, but we also have can get spectral information, so we have another dimension. So we can look at these things as a function of wavelength, which is interesting, tells us more about the atmosphere there and sort of different heights or different aspects of the atmosphere. And of course, we can do this as a function of time. And so now we have whole time series. So yet another more data, more information, another dimension that we can sort of identify behavior in the sun's atmosphere, evolution and so on. And we see all kinds of different structures. You see these long fibrils again, magnetic field, and you see complex behavior. And then, the final dimension we have to deal with, I won't be talking about, but just to mention it is of course polarimetry. So we can get magnetic field information out by measuring different polarization states. So the big question is, how do we have all this data? There's a lot of things going on at different spatial scales, spatial structures. Things are evolving. So how do we efficiently extract information from these big multidimensional data cubes. And this isn't a new question, and there are many methods out there for feature recognition. 10 years ago, Marcus Eschwanden, did this survey of all the different methods, and I don't expect you, and I will not go through all these different methods, but he sort of looked at a lot of different ways of extracting this information, of sort of pulling out different events, different detections for a variety of features, from filaments and prominences to flares and waves. Anyway, and so there's this whole large zoo of methods, and we won't be trying to address all of these in this project, but we sort of identified three key areas where we would try to get some of these key tools and methods implemented in a standard way in Python, in SunPy, and in the PyHC framework. So I'll go through and just give a quick overview of what these three are. One is loop and fibril tracing. So as I mentioned, we see these magnetic fibrils in the chromosphere, in the corona. These sort of manifest as these bright loops we often see. And there are tools out there for sort of picking out, and our eye sort of, we can say, oh yeah, this sort of seems like a coronal loop. Doing that algorithmically, our eye is very good at that, but sort of an algorithm that can sort of reproduce and sort of trace out these loops and give them as a function, or as positions in the field of view, is a little more complicated. But there's one, the variety we'll look at. One we're focused on, or one of the key ones used, is called OCCULT, oriented coronal curved loop tracing. So you see these orange lines over here are some of the coronal loops that have been identified in this image on the left. Some of them seem reasonable, others are sort of maybe less, artifacts. Obviously, it picks out a lot of things. But this is, there's other techniques. This is another one using just a thresholding and sort of union finding, and then fitting polynomials to these various loops in the chromospheric fibrils. So, you take an input image, threshold it, and, join the various segments, fit those, and then you can sort of look at orientations in the field of view, which is, interesting scientifically. Tells you about, again, magnetic field. The other technique, or the other method we want to address, is spatio-temporal feature tracking. So we can identify in our images some of these features based on certain characteristics that are particular to that particular kind of feature. For example, in these iris UV images, there are all these bright points that appear, sites of local heating in the chromosphere. And so, can pick out these things as, temporal excesses above, some background, and then try to track them through time and see how they evolve. These things, are moving and evolving continuously. So you look at this, time series, and then this color coding here tells you the number of times one of these features sort of fragments and into multiple sort of sub features. So obviously this is sort of a complex problem to track all these little different bright points. And then the third, method we identified as needing some better development is, or, to the solar case, is what we call spectral decomposition. And so we have these observations of spectral lines, but it turns out, this is sort of, all these spectral lines share some similarity, or observations of the same spectral line at multiple times or in, similar features, have a lot of similarity to one another. And this, falls into the realm of data sparsity, where we can take multiple spectra, break them down into a set of sort of fundamental components, whether these are sort of eigenmodes or orthogonal components, and represent a spectrum, an observed spectrum by a linear combination of these different components. So the original blue observation, by combining a series of components of different shapes, the green one here, and then we have other, there's other components shown here, this orange one, and the blue one here encode information about the spectral line, sort of the velocity or intensity, and you can reconstruct your original observed spectra pretty well. That's that orange line.
Hey, Given.
Yeah.
Yeah.
The slide previous, please.
The slide previous, yeah.
Yep, there you go. I'm wondering, well, first the obvious question, doing this kind of comparison can help detect kind of more anomalous behavior in your time series data, right? To maybe find things like flares or some other things like that.
Right.
Right. And how far do you go into the whole like modeling the maybe the yearly trends, the seasonality of the data or anything like that? Is it just principal component analysis, or do you have like extra layers of modeling, I guess?
Yeah, I mean, some of those trends, I haven't seen, it would be an interesting way to look for those trends to see, if you could compare sort of the components at different times, or if you took a long time series. In general, we're looking at time series acquired over shorter intervals, spectra taken over, hours or something.
Gotcha.
And breaking them down.
So no, not yearly cycle.
Not
right?
yearly, cyclical, but
yeah,
that's interesting. We do have, long-term time series of integrated sunlight spectra. It'd be interesting to see what those components, how those could be decomposed.
Neat.
So as an example of this time series, this is a sunspot here. And if you look in the spectrum of this calcium line, this is a time series of the spectrum. And so sometimes, it gets bright and you see this back and forth that, sort of indicates a velocity. But what's neat is if I, use something like PCA, in this case, it's a little different technique, proper orthogonal decomposition, but I can sort of break down my spectrum, and these are sort of the three primary components. And, I can sort of see the velocity changes are captured in this bottom one, some of these intensity brightenings in the middle, and, this is sort of the average, that first mode is sort of the average spectrum. And so I can actually pull out physical sort of information more easily this way than trying to, fit these highly variable line profiles. But yeah, that, doing the same thing with, it'd be more subtle, the long-term changes of the solar spectrum, integrated solar spectrum, but it would be interesting. So getting back, to the specifics here of the project. So our goal is to implement some of these new feature recognition tools and in the PyHC environment. Where implementation is part implementation of the actual method and part taking some existing tools and making them more, testing them and making them more applicable to the solar case, as we'll see. And so there's some of this is already, some of these, the natural home for this will be in SunKit image, a lot of this, which has, some of these things implemented already. OCCULT-2 was written originally in IDL. There's sort of a direct translation of that into SunPy, and so that's sort of available. And so, yeah, hopefully, a lot of some of these other methods will be incorporated into SunKit image. So, OCCULT-2, as I said, is implemented. We're going to be looking at trying to define and optimize some of the parameters for different cases, develop sort of a gallery or some tutorials on using that for the coronal, for chromospheric, maybe for some of the solar orbiter data. Turns out it's interesting identifying these loops, in one direction is interesting because then you sort of can trace out the loop. With solar orbiter and SDO, we can actually look from two perspectives at once, at these loops at fairly high resolution. And so we can actually then get not just we get the tracing, hopefully, of the same loop. A lot of questions as to whether these are actually loops at all, but from two different perspectives, and combine these two sort of loop identification or loop tracings from multiple perspectives. So that's going to be interesting. The OCCULT-2 is one loop tracing code. There are a lot of several other ones out there, and that have been developed. This was sort of a survey, a comparison done back in 2008, comparing this a variety of different methods, all similar in trying to parse out, identify segments of these loops based on different sort of aspects of their what's considered fundamental, whether it's the curvature, whether it's their intensity variations. And so, yeah, this is, we may look into implementing some of these other techniques that may be interesting or suitable in SunKit image. One that's been used, starting to be used now, is what's called the rolling Hough transform. So the Hough transform is sort of an edge detection method. The rolling Hough transform sort of tries to use that to identify these sort of extended curvilinear features. And so you see the map here of an image of fibrils with the rolling Hough transform applied. And we've done some initial tests comparing that map to the fibrils that were identified with the OCCULT-2 in SunKit image. And you see, there is some similarity. There are some loops that are, some structures that are identified with the rolling Hough transform that aren't identified with OCCULT-2. So it will be interesting to try to implement that. There's actually a library that does the rolling Hough transform, but to make that applicable to the solar case will be valuable. The other one was the spatio-temporal tracking. So, there are a lot of codes out there for sort of, identifying. In that one case I showed were bright points, or they could be magnetic features, which, have a little different characteristics in their behavior and have there's a different sort of algorithm out there people have used to track those, or to look for impulsive brightenings, whether these are small flares or large flares. But basically, it's to we've identified a couple of these codes. So convert those into a lot of these have been developed in IDL, or some key ones exist in IDL. We want to convert those and generalize them to some extent into Python. Looking at sort of better definition of some of these. They all sort of, a lot of them are tuned on specific thresholds, timelines, certain specific characteristics of these structures in the time series. So how to define those different parameters of the identification. And then the temporal tracking is a common problem among these codes. And there's a lot of work in computer vision in sort of identifying tracking features in time. and space. So to what extent can some of those, existing toolkits be applied here? And a big one will also be, we can sort of identify these structures in the pixel framework pretty well, which pixels had a feature at a certain time. It would be very nice to propagate the solar coordinate information in the record of the feature. And, one way to do that is to do this processing, allow this spatio-temporal tracking to occur on an ND cube object, which sort of carries that coordination information with it. And then the last one is the spectral decomposition. And in this case, a lot of these tools for PCA, k-means clustering, and so on already exist, but how to have an effective interface with solar data and make it easy for users to sort of figure out which one of these is the right tool, and which can be used for the spectral decomposition. Spectral decomposition, I forgot to mention, is useful both for sort of identifying features. It's also a great data compression tool, since it sort of can collapse a lot of data down by identifying, the primary information, what's the primary information in the data, and sort of those higher level components, are usually just noise. And so those, can be eliminated to save storage space. And then they, just to finish up, there's a few sort of explorations we'll be doing, how to include some of these existing tools to improve the efficiency and maintainability of this, these methods for solar data. OpenCV has a lot of things in there. There's for, ridge detection, which is very similar to, a lot of similarities to loop finding. Scikit image has some of that. Some cases, some of this might, there was large data cubes, large data sets, using things like Dask might be very useful. And then, looking at whether, some of these things can eventually be extended to machine learning. It's not a specific focus, within this project necessarily, but thinking about that. And, GPU acceleration is another possible way to improve some of the, how long it takes to do some of these feature recognition applications on large data sets. So yeah, I'll stop there and happy to take any questions. Thanks.
Awesome. Thanks, Kevin.
Mm-hmm.
Let's see. There was one comment in the chat that said, regarding multiple viewpoints, it would be nice to have an implementation of Marcus's tools for 3D reconstruction of loop geometries for multiple 2D projections.
Mm-hmm.
So I guess just food for thought.
Yeah, no, that would be, the first step is getting those different 2D projections. And yeah, some of that work on, the coordinates, I think, being able to understand those different observer viewpoints, have those tied in, I think will be great for that.
For sure. Does anyone else have any questions they'd like to pose to Kevin?
So yeah, I'm the one who asked that question in the chat. So do you have a feel for, given all the coordinate transform capabilities that we already have in the, via the coordinate frames that we implement in SunPy on top of the AstroPy coord stack, like, do you have a feel for how much of that work is already, how much of the work in like Marcus's 3D reconstruction package, how much of that work is already done by the coordinate stack?
Mm-hmm.
I would imagine a lot of it.
I think a lot of it, right? I mean, that's my hope, is a lot of it has been done, right? And right now we sort of identify these things, and they're just, sort of a collection of pixel coordinates in the image, right? Or a mask in the image, and then we, so hopefully, it's fairly straightforward to, just to then go to the coordinates and use all the framework that's been built up to do that.
Yeah.
Getting to that 3D is more complicated just because, this is a projection. You have two projections onto a plane, right? So it's not the location of the fibril is not unique, right? It could be
Right.
any, multiple height, points along the line of sight. This is optically thin and generally, and so, and then there's a whole scientific question about whether these are actually loops at all and whether the 3D reconstruction makes any sense, but that's this will enable those kinds of studies. So yeah, our goal is to focus on the identification of the, location of these fibrils in the projected image, and then lean on the existing coordinate framework.
Right. Yeah, I think with your slide about the loop tracing, I think, and Nabil and I have talked about this a bit too, it'd be really great to have sort of like a general like tracing interface, and then have these like multiple like basically backends for doing the loop tracing, like the OCCULT or these other various methods, and you can kind of choose your method, right? But then there's sort of a framework for doing the tracing, and then you get out, no matter what algorithm you choose, you just get out a list of your coordinate objects, from whatever the coordinate system of the image that you're tracing. And so it takes in, I think right now where the input is a SunPy map, it probably at some point should be like an ND cube. So then you can get some, more general interface, and then you get out their coordinates in whatever, based on the WCS of your input image. And then it makes doing this comparison like between a bunch of these really mix and match whatever ones you want.
Right, because there's not one right way to do it. It sort of depends on what kind of features you're trying to identify.
Exactly. Yeah.
And so on. So it's it'd be great to have that sort of common interface, and then
it would
common output.
Like spec that out, and then you guys can start kind of injecting like kind of pieces into. I mean, we could even do it with just the existing OCCULT-2 one. It's sort of a trio case of like the n equals 1,
right?
But then it's just and then add on top of that as more become developed.
Yeah, that would be great.
Awesome. Thanks, Will. Any other questions, comments, thoughts for Kevin?
I'd like to jump in with one real quick.
Go ahead.
On one of the slides you were showing just a second ago, you had a machine learning toolkit bullet point there. And it got me thinking, we've had a couple of presentations lately from people in this community who are developing machine learning tools for studying the sun, et cetera. And I'm wondering how plug and playable this might be, if this might be an opportunity for the people who are developing machine learning capabilities here to stick it into whatever pipeline that you have.
I mean, you can't have a slide now without machine learning, or presentation. I mean, I think there are a lot of possibilities there. Just by the nature of the problem, right? We're trying to, we see these features, we can sort of identify them. A lot of times it's sort of a conceptual identification. This is the kind of feature. And, like in this case, we can, trace them out manually and sort of give a training data set. And then, they occur a lot. And so it seems a natural case to, to allow you to apply these techniques to a lot of data. So yeah, I mean, it's a good, one of the problems here is there are, millions of loops and thousands of bright points and so on, right? I mean, to what extent do we need to identify them all is another question, but yeah, Benoit on this project is, has a lot of experience with machine learning and so on, and
nice.
So he's definitely interested in that component of it.
I guess this is sort of a low level question here, but the way the code base is set up, do you have the machine learning bits separated into its own module or its own class, something that'd be easy to extend, or is it all kind of mixed in with all of the main stuff?
Yeah, I mean, we're still, we're just getting started now, really.
That's right. Yeah.
Right. So, it's still, conceptual at this point. But yeah, I mean, I think the goal would be to keep the machine learning, or, if there's some kind of, GPU acceleration that can be done, keep that sort of separate and not have it all
definitely
tightly coupled.
Definitely advocate for good abstraction and
right,
creating modules and all that stuff.
Mm-hmm.
Cool. Thank you.
Thanks, Sean.
Any other questions? Great. Thanks again, Kevin.
Mm-hmm.
Looking forward to
Thank
seeing
you.
the results of all this.
Thanks.
Of course. Okay, so sorry, switching tabs. One thing that came up kind of as a sidebar discussion during the summer school between those of us organizers was, kind of talking about all the various communication options that we have in PyHC, and what might be the best one, how to push forward with that, and so forth. So, for example, we have, the element matrix chat space that it's mostly a couple conversations that'll pop up, but a lot of it's me sending out meeting and telecon reminders, and that's kind of the bulk of it for that. We have technically a Helionauts like private space that not everyone yet is on, but there are a good amount of people there. It's kind of a nice way to connect with the larger heliophysics space of the community. During the summer school, we used a free version of Slack because that was just a really easy option, especially for Sean and I, who use Slack all the time at work. That's LASP's main way of communicating other than email. So I was just kind of curious of, the community's thoughts here of, how to push forward in the future, because we do have this matrix element channel that would be good to get discussions going on, kind of any kind, just a way for the community and all of us to talk amongst each other. But it's kind of dead in there, and I'm not sure of the best way to encourage people to really use it. It is like one more, communication method to keep open constantly among all of the various things you already have, I'm sure. But I just wanted to, get a pulse for what people think on this.
I'd also be kind of curious to know how wide the Slack adoption is among this group, simply because the way you can split up conversations into channels easily on Slack and stuff, that was facilitating a lot of great discussion and activity during the summer school, like you said.
Yeah, I like Slack a lot just because I'm very familiar with it, and it's very well put together in my mind. I don't know. I know some probably don't agree with that assessment, but
we have a bias there.
Yeah, just a little bit. But the free version, it is limited after 10,000 messages, it starts quietly getting rid of all of the oldest messages one by one, which isn't necessarily ideal, but the paid version starts getting a bit expensive from what I've heard. So yeah.
I doubt we even have 10,000 messages total in Element.
Not yet. Definitely not yet.
Yeah.
Slack. Let's see, Rebecca. Slack and email, I'm fine with. I don't know if charges don't.
Yeah.
Yeah, that was another part of the sidebar discussion we were all having. Nick, thoughts? Your mic is showing unmuted, but I can't hear you.
Oops.
Oh, sorry, kid.
Definitely quiet for me too.
Yes, but you're very quiet.
Oh, hey, Julie, do you remember how to do like polls here in Zoom?
Oh goodness, I think you. Oh wait, there's a button. Polls quizzes at the bottom by share screen. Do you see that, or is it just me?
Dang, no, that's not me. Apparently only you can do that.
I guess it's one of those Zoom settings I need to click.
While Nick gets his microphone figured out, would you hate creating a quick element versus Slack poll? Get people to
Sure.
pop in a little thought. Not that we're going to take any action on this per se. I'm curious to.
No, it's good to know. It's good to know.
Yep.
So do you see Nick's message in the chat?
Oh, nice.
Can someone else take a look at that?
So activity and element and or Slack could be communicated both ways so that people can kind of just pick whatever. I'm going to guess that would work something like the element room would just become a channel in Slack if you wanted to. And then I'm not really sure how Slack messages would funnel into element, but I can see how that could start to work.
Yeah. Ooh, okay. Looks like people have seen the poll. This is kind of
Cool.
fun. It updates real time.
Thanks, guys.
Well, it kind of goes right in your face, so.
Yeah, that's good to know. For me, it's just like I have an extra little window open off to the side. I've never seen it.
But no,
I've just seen a
definitely
poll
like the
in
idea
Zoom time.
of doing a bridge there. Yeah. You know, it's always annoying to add one more, communication channel for people to remember. So I definitely
Mhm.
like being able to do something in the background so that you don't have to change your workflow if you don't want to.
Yeah. Nick, there could be an element room for every Slack channel so that all the communication could be done in both. If we do the bridge, then all the history would be stored on element, which is nice. I don't think there's a limit to history you can save on element. Someone correct me if I'm wrong. I've never seen anything like that.
No, yeah, they're
Perfect. Okay, so that would be one nice way to still keep the Slack space for those who like to use it, but then, okay.
nice.
For
So
what
what's,
it's,
Nick, is that facilitated through a Slack plugin or an element plugin? No, that's okay.
to be researched, to be researched.
Okay. I can go to the Google.
The Google
Sounds
will
good
have
to
the
me, man.
answer you desire, I'm sure. Could be an integration more than a plugin. That's true. That's true. For what it's worth, as far as communication methods go, we had 9, 11, 13 votes total, 9 for Slack. So a lot of people also use Slack. So worth considering keeping it open just for that sake. Element, 2 out of 13 voted for element. Still going strong, guys, for the open source option. And then other is 2. I'm curious what the
Was
other.
it a vote for it, or it was which one we
Was it-
used?
Which communication do you all use the most?
I use Slack the most, but I might vote for Element.
Okay.
Nice.
There we go. The most. So a lot of people are using Slack right now. I guess that's what's to be pulled away from
We
it. Element, a couple
unfortunately,
in there.
unfortunately at NASA, we're sort of bound to use Microsoft stuff. We use Teams,
Mhm. That's fair.
and I don't know. I find with any of these things, I end up with so many different conversations going on that it's hard to follow no matter what. But
Yeah. That's for sure. That's for sure. Rebecca AAS used Slack.
What
It's a
about-
really easy option to go with. It's very well known by a lot of people. So,
Discord.
oh, Discord. I'm curious. Does anyone else use Discord? I don't know if I've ever used it in a professional setting. Isn't it kind of like a off-brand Slack with
Yeah,
a
I've
bit
always
more
used
gaming options?
more like D&D than like science, right?
We've used it as sort of a Slack, like, you can have groups, and within our research group, we use it.
Fair enough. Apparently Komodo uses Discord. That's good to know. I'm hesitant to add another communication method, but
Yeah, it wasn't necessarily a suggestion.
for sure, for sure.
I'll
Yeah, please don't.
I'll make a note for myself to look into the element / Slack thing, and I'll consider taking some action on that. Maybe
Awesome.
at a future Telecon, not this one.
Yeah, fair enough. In that case, if we keep up the Slack space, we have it currently called PyHC Summer School, but if we want it to just stay a bit more open than that, we could consider changing that. I'm not sure.
I mean, I
Something
can
to
just
think
make a
about.
I can just make a new general PyHC workspace. That wouldn't be hard.
Fair enough. Fair enough.
Summer school people are still trickling in some conversations about the summer school and the packages presented there, so wouldn't want to step on their toes.
Yeah, definitely. Although that has slowed down, so I guess it's not a huge concern at this point, I suppose. We can advertise the summer school list once we have a Slack space up that exists, or Matrix Element. I think Matrix is the old name, Element's the new one. Cool. Alrighty. Well,
Yep.
I think that's all I had on that idea. It was just a conversation that came up amongst some of us in the org committee for the last summer school. So I thought, let's just ask the community. Rebecca.
So congrats to Sean for submitting the paper.
Hey, that's also right. I
Good
could have
job.
mentioned that as new top of this telecon.
Oh yeah, I submitted a PyHC paper to the ACER, Advances in Space Research. I'm forgetting the entire acronym. It was accepted with minor reviews, so working through those now.
Congrats to Julie then too. I had no idea. I forgot.
Honestly, I've had so many things going on, so had I. Reminder. Yeah, thanks, Rebecca, and big congrats to Sean. Yay for executable papers being submitted, I should say.
Yep, it's the title is Making an Executable Paper with the Python and Heliophysics Community to Foster Open Science and Improve Reproducibility. Submitted to Frontiers in Astronomy and Space Sciences.
Awesome. Definitely keep us posted on how that goes. Crossing
will.
all the fingers that they accept it and like it. I think it's a great way to do papers.
It'll be
for
the
software.
very first paper that me and the editors I'm talking to could find in the journal that will include code, which seems very silly to me. They have tech papers as a whole category of articles you can submit, but every other paper that's submitted, like in history, apparently people just use English prose to describe what their code is doing instead of just literally showing the code. Like we had to come up with a new way to even present code with like syntax highlighting when I submitted this paper. So
interesting.
Feels like very low hanging fruit to me, but we're breaking some new ground apparently.
Hey, someone's got to do it. Why not PyHC?
Yep.
In my mind, it's fitting with our ethos.
Hey, Sean, if you have any hints on how to do that syntax highlighting, I'm going to need that for the fly-through paper.
Oh,
the same journal.
I just took screenshots from.
Oh, screenshots? Okay.
Stuck the images in the paper. Yep.
I already did that. Okay.
Yeah. Baby steps. Maybe there'll be a more refined method with time. Cool. Okay. Well, it sounds like great job on papers, and then it sounds like we have some ideas moving forward for PyHC communication methods. We'll keep up Slack since a lot of us do use it, and then bridge between that and Elements. So, sorry, my cats are growling at each other. Anyway, so the last thing I wanted to do today was just do a quick check-in on white paper for the upcoming decadal survey things and see what progress is looking like. There was the RSC paper, which I think, Rebecca, you've been, you had like a meeting about that last week. I couldn't go. Oh, go ahead.
Well, there's new feedback from the forming committee stuff. I'm not finding all the right words. It's Monday morning. But
No worries.
they're saying now that, well, the call hasn't come out yet, and it was supposed to come out on the 15th, so they're running late. But the warning is now that when it does come out, we'll probably only have 4 weeks to pull it together and submit it. So don't count on much time.
Mm-hmm.
It's for the white papers.
I think the call just came out.
Oh, really? Can you post a link to the chat?
Oh, that'd be great. Thanks, John. Let's see. Do we have more than 4 weeks? Okay, that's taking a moment to load. The due date for white
Yeah.
papers is August 18th. Okay.
Okay. Woo, more than 4 weeks. That's good.
we still have a moment. That is good to know.
Yeah. Thanks, John.
Yeah, thanks. In any case, what was I going to say? Oh yeah, I know for sure, Rebecca, that you had a meeting regarding at least one of the white papers last week. I was just curious about the results of that. I'm sorry, I haven't gotten to look at the link you sent out for it yet.
Oh, there's a lot of good discussion. I don't remember much of it because I had Cedar and Jim last week, and that meeting was the week before. But
Yeah, Cedar.
there's a lot of comments in there, and if you have a link to it, feel free to keep adding comments. If you want a link to it, just email me or someone else.
Cool.
Just email me. I don't know. I don't remember who else. I know Nick's on there and Kevin, but I don't remember. It's too much in my head.
Sounds good.
Yeah, you had something like 8 people on the last meeting, didn't you?
I don't remember. There was quite a few. I mean, not unmanageable, but
Quite a few.
a good number of people.
Gotcha. I'm just going to scroll through the other names for papers that I see here. Forget the atomic data needs and accessibility for heliophysics. Sean and Nick's names are on that. Is that still happening? Maybe not much progress has been done on it, which is totally fine. Let's see. We had a white paper idea for making software interoperable, fixing conflicting dependencies, similar interfaces, etc. Whose names are on that? Russell, John, Rebecca. I'm not sure if anything's been done with that from you all.
Well, that's in Russell's court. He has to draft this.
Russell here. Since CDR's last week, I've been focused on that, so I haven't done anything on the white papers.
Yeah, no worries. This is just a check-in. Also, thanks for the invite to present on PyHC in our summer school at CDAR.
Oh, of course. I'm glad
I
to be able to make it.
Sure. And Rebecca, you had a great presentation regarding Komodo stuff too. Let's see, the next paper was PyHC community overview, which is definitely in my court. And I have no updates on that either because the last couple weeks have been a bit wild. Let's see. So the next one, build an online searchable library system, data archives, model archives, software archives, searchable software and high performance computing services system. It just has your names, Rebecca and Sean.
I have a draft. I had that last year, to be honest.
Hey, it still works.
Yeah. That's the whole liked in diaries thing, right?
I guess so.
That's the only other draft I have, so that's what I'm gonna go for.
Pretty sure, yes.
Yeah. So
Which Rebecca, maybe now this is a weird time to bring it up, but I should mention that your diaries thing was brought up by someone in an email chain somewhere. Maybe it was Arno, but I might be remembering incorrectly. As we might potentially be poking you to talk about that at one of our AGU sessions.
as you wish. I typically do the talk as a pair because one builds on another.
Good to know.
Let us know. Let us
Yeah.
know. Wow. Okay, let me know. I'm sorry. I'm just gonna be quiet.
You're totally fine.
Yeah.
I'm just going through more topics to see if we had any notes about not doing them week after Gem being okay. That was from Rebecca. Software sustainability. Have we decided to go with that? Or was this? I thought leave it to someone else. Software sustainability for PyHC. The names on it are Nick and Rebecca. Oh,
Hey,
cool. We have our redirect already.
Yeah, I was gonna say I might interrupt for a quick second.
Yeah, go ahead. That's awesome.
I should I should shower Pete Riley here with praise. We've been talking in the background here about the PyHC.org domain during this meeting, and he went ahead and purchased it for us on behalf of PSI. And I think it's working now. I just stuck an http://pyhc.org in the chat there. When I click it, it pulls up heliopython.org, but it takes a while to process through the internet. So it might not work as you click right now, but yeah, wow, that already happened. So woohoo.
Our pleasure. For $15, it was well worth the effort.
Yes, many thanks,
That's
Pete.
amazing.
Well done, PSI. I agree. Nick, haven't done anything on software sustainability paper, still interested depending on time constraints. Okay, cool. Good to know.
Access to that site is restricted from NASA for now.
It needs an S.
Or is it
Yeah,
just
so
HTTP.
yeah, so I need to add the SSL certificate onto it as well. But
Okay.
but at least nobody can poach the URL now.
I know that's good, but
Hmm.
the S is critical.
The redirect still falls back to the HTTPS security we have for the heliopython.org domain. So that's a tiny little band-aid that'll come soon enough.
Fair enough. Fair enough. Well, awesome. That's a great first step. Thanks again, Pete.
And I'm blown away. I didn't
Input.
expect it to happen for like another month or two. We were going to have to do a lot more bureaucracy over here at last.
No.
Yeah, we don't have that here.
Totally fair. Let's see. What about there's an educational resources paper? I wonder if that has to do with some of the other papers above, whose names were even on this. Include important bits from this and include another white papers, not a PhD paper. Never mind, we're moving along. Oh, I think that actually completes our white papers. So cool. Thanks everyone for letting me know where you all are at. No worries if you haven't been able to make progress yet. Obviously, this isn't due, as we know now, until August 18th, so we should be good to go. And hopefully I can get started working on that PyHC community overview one soon. I have a whole paper about that, so I'm sure I could pare something down into a white paper format. Well, that's all I have for today. Our next telecon is going to be on July 11th, same time, same place, topics TBD. So I guess I will see you all again there.
Okay, bye.
And
Yeah.